Till now we have learned about direction ratios and direction cosines. One thing that I want to mention over here is that before going through this chapter, three-dimensional geometry, you must know the concepts of vector algebra. So, you should revise the chapter of vectors before going through the chapter three-dimensional geometry. So let's move on further. The next topic we are going to discuss is equation of line in space. Till now, we have learned to find equation of line in two dimensions only. Here we will learn to find vector and Cartesian equation of line in space. Now you should know some concepts before that. We get a unique line when, first case, when the line passes through a given point, and has a direction, So if we are given a point through which the line passes and a direction associated with that line, then we can find out the equation of line uniquely. And second case is when it passes through two given points. So in these two cases, we can find out the equation of a line uniquely. So let's discuss these cases one by one. Let's take the first case. The first case is to find the equation of line through a given point and parallel to a given vector. So in this case, what we are given to us? We are given a point and a vector to which the line is parallel. We will find out the equations in the vector form as well as Cartesian form. So let's discuss the vector form first. Let V vector is the vector parallel to the line. So line is parallel to the vector V, and P vector, small p vector, be the position vector of given point P. So the line passes to the point P whose position vector is P vector, and the line is parallel to vector V. Now let vector R be the position vector of an arbitrary point R on line. Suppose on the line there is a arbitrary point R whose position vector is vector R. So the scenario can be depicted as follows. Suppose this is x-axis, this is y-axis, and this is z-axis. This is the origin. Suppose this is our line. L. There are 2 points on this line. One is the given point P and other is the random point, or you can say the arbitrary point R. Now we are given that the position vector of P, that is the OP vector. This OP vector, its position vector is given to us as P vector, and this is the position vector of point R, and it is denoted by vector R. Now let's say this is the vector V, which is parallel to the given line. So the line gets a direction which is from P to R. So this is the given point P whose position vector is P vector. This is a random point or arbitrary point R, general point R on the line whose position vector is R vector. And this is V vector to which the line is parallel. Now here, since PR vector is parallel to V vector, therefore we can write vector PR equals to lambda times vector V, where lambda is a parameter and lambda belongs to set of real numbers. Now by triangle law of addition, by triangle law of vector addition, we know that here OR vector, there's a triangle OPR. In this triangle, OR vector can be written as OP vector plus PR vector. OP vector plus PR vector. I've told you earlier, to understand the concepts of three-dimensional geometry, you must have gone through the chapter vector algebra. So if you are not able to get the equations over here, you can go through the chapter of vectors. You can revise that chapter. So from here, the triangle law of vector addition, OR vector will be equals to OP vector plus PR vector. Here, the position vector OR vector is denoted by R vector. The position vector of point P, that is OP vector, is P vector plus PR vector written over here, which is equals to lambda times V vector. So here it is lambda times V vector. So the equation over here, R vector equals to P vector plus lambda times V vector, is the required vector equation of line. Required vector equation of line in space. Now just to memorize it, you can observe that I've written it like this. R vector equals to P vector plus lambda times V vector, where P here denotes the position vector of the point and V here denotes the parallel vector. So to write the vector equation of a line, we just need the position vector of the point, the given point, and a vector parallel to the given line. Here lambda is a parameter which is a real number. By changing the values of lambda, we can get the different position vectors of different points on this particular line. Now let's convert this vector equation into Cartesian form. For that purpose, now we are going to convert this vector equation into Cartesian form. For that purpose, let the coordinates of point P be x1, y1, z1, and the coordinates of point R, random point R, be x, y, z. Therefore, the position vector, that is P vector, will become x1 I cap plus y1 j cap plus z1 k cap, and R vector will be xi cap plus yj cap plus z k cap. And let V vector, the parallel vector, is ai cap plus bj cap plus ck cap, where A, B, C are direction ratios of vector V, where ABC denotes the direction ratios of vector. Now in this scenario, we know that by the vector equation, we know that R vector can be written as P vector plus lambda times V vector for some lambda belongs to R. So let's replace the values of R vector, P vector and V vector over here. So you will get xi cap plus yj cap plus zk cap equals to x1 I cap plus y1 j cap plus z1 k cap plus lambda times v vector, that is ai cap plus bj cap plus c k cap. Now from here, equating the coefficients, of I cap, j cap and k cap from both sides, we get from here the coefficient of I cap is x, and from here the coefficient of I cap is x1 plus lambda times a, x1 plus lambda times a. Similarly from here the coefficient of j cap is y, and from here the coefficient of j cap is y1 plus lambda times b. From here the coefficient of k cap is z, and from here the coefficient of k cap would be z1 plus lambda c. So from here you can get x minus x1 upon a equals lambda. From here you can get y minus y1 upon b equals lambda, and from here you can get z minus z1 upon c equals lambda. So from these three equations, since the RHS are equal, so we can equate the LHS part. So we will get x minus x1 upon a equals y minus y1 upon b equals z minus z1 upon c. So this equation over here is the Cartesian form of a line, or Cartesian form of equation of line in space. This is the required Cartesian equation of line in space. Here you can see x1, y1, z1 are the coordinates of the given point, and a, b, c are the DRs, direction ratios, of the vector parallel to the line. Now let's do some questions on the basis of the above concepts. Let's take the first question. Find equation of line in vector as well as Cartesian form through point 1, 2, 3 and is parallel to vector 3i cap plus 2j cap minus 2k cap. So we need to find the vector as well as Cartesian equation of this line. What we are given? We are given a point and a vector parallel to the line. So let's first write down the position vector of the point, which is going to be 1i cap plus 2j cap plus 3k cap. Let's take our vector as xi cap plus yj cap plus zk cap. What is the v vector? V vector is 3i cap plus 2j cap minus 2k cap. Now there is no need to write down the vector form of our vector. We just need these two things: the position vector of the point and the parallel vector. Point, parallel vector. Point, P for point, P for parallel vector. So the equation becomes R vector equals to P vector plus lambda times V vector, where lambda belongs to R. So the vector equation is R vector equals to I cap plus 2j cap plus 3k cap plus lambda times 3i cap plus 2j cap minus 2k cap. This is the vector form of given line. For writing down the Cartesian form, what we need to do is we need to put the values of R, P and V and then equate the coefficient of I, J, K. So it will be reduced to x minus x1 upon a equals y minus y1 upon b equals z minus z1 upon c. Now here the point P is 1, 2, 3. So x1, y1, z1 are given to you. And drs. Let's talk about the drs. The drs are basically the coefficients of I, j, k in the v vector, which is 3, 2 and minus 2. So drs are 3, 2 and minus 2 in that order. So the equation will become x minus 1 upon 3 equals to y minus 2 x minus 1 upon 3. Then y minus 2 upon 2. And then z minus 3, this is z minus 3 upon minus 2. So this is the Cartesian form of the given line. Let's take another question. Let's take another question. The question is, find Cartesian equation of line which passes through point minus 2, 4, minus 5 and parallel to line the line x plus 3 upon 3 equals to y minus 4 upon 5 equals to z plus 8 upon 6. Now we are given a point and we are given a line. In this case, you are not given a vector parallel to the line of which we need to find the equation. But remember, when you need to find the Cartesian equation, you just need a point which is given to you as minus 2, 4, minus 5. And what else you need is the drs of a vector which is parallel to the line. So from this line you can find out the drs. This is the Cartesian equation of a line and the denominators over here are called drs. Now suppose if we somewhat change the question like this. I'm changing the question. Suppose the equation of the line is given to you in this format. X plus 3 upon 3 equals to 4 minus y upon minus 5 equals to z plus 8 upon 6. What I have changed is I have multiplied the numerator and denominator over here with minus sign. So it becomes 4 minus y and it becomes minus y. Now what is the difference? The difference is that this is the standard form of line in Cartesian form. So this is the standard Cartesian equation where the variable x, y, z are first term and then the numbers are written. In that scenario, we say that the denominators are direction ratios. But if you look over here, in the second term, y is in the second term and 4 comes before it. So this is not the standard form. So if the equation of line is given to you in this format, in that scenario, the direction ratios will not be the denominators over here. Firstly, you have to convert the equation into standard form in which the variables will come first and then the numbers will come. In that scenario, the denominator will become the drs. So these 3, minus 5, 6 are not the drs because this is not in the standard form. Here 3, 5 and 6 are the drs. So the drs are 3, 5, 6. So the Cartesian equation is x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c. So it will become x plus 2 minus minus will become plus upon 3 equals to y minus 4 upon 5 equals to z minus minus 5, it will become plus 5 upon 6. So this is the required Cartesian equation. Now let's move on further. Now we will discuss equation of line passing through two given points. In the earlier case, we were given a point and a vector parallel to the line. But here, what is given to us? We are given 2 points through which our line passes. In that scenario, we need to find the equation of line. Let's start with the vector equation. Vector form. For that purpose, suppose you are given the line. Suppose this is the line L. This line passes through 2 points. Let's say A, let's say P and Q. Assume that position vector of point P is P vector and position vector of point Q is Q vector. P vector is the position vector of point P and Q vector is the position vector of point Q. Now let's assume there's another arbitrary point R on this line and assume that the position vector of point R is R vector. Suppose R vector is the position vector of this point R. So 2 points P and Q are given to us and we have assumed another point R on the line whose position vector is R vector. So from here, if you need to find a vector parallel to the given line, then that vector could be PQ vector. Since we know the position vector of P and PQ is the line vector, so this line vector can be written as Q vector minus P. Now from vector equation of line, we know that the vector equation can be written as R vector equals to a point vector which is P vector over here plus lambda times a parallel vector. We have assumed that V vector is the parallel vector which can be written as Q vector minus P vector. So this equation over here is the vector equation of the line when we are given that the line passes through 2 given points. So this is the vector equation. Now let's convert it into Cartesian form. Cartesian form. So for that purpose, we are given 2 points. The point P, assume that the coordinates of this point are x1, y1, z1, and the point Q, assume that its coordinates are x2, y2, z2. And let's say the arbitrary point R has the coordinates as x, y, z. So P vector will become x1 I cap plus y1 j cap plus z1 k cap. Q vector will be equivalent to x2 I cap plus y2 j cap plus z2 k cap, and R vector will be equals to x I cap plus y j cap plus z k cap. Now from vector equation we have that R vector is equals to P vector plus lambda times Q vector minus P vector. Now we will substitute the values of P, Q and R vector over here. We will get x I cap plus y j cap plus z k cap equals to x1 I cap plus y1 j cap plus z1 k cap plus lambda times Q vector, that is x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap plus y1 j cap plus z1 k cap. Now we have substituted the values. Let's simplify it. What we are going to do over here now, we'll equate the coefficients. We'll equate the coefficients of I cap, j cap and k cap. After doing so, what we will get is x equals to x1 plus lambda times x2 minus x1. Here we will get y equals to y1 plus lambda times y2 minus y1, and z equals to z1 plus lambda times z2 minus z1. On simplification, you will get x minus x1 upon x2 minus x1 equals to lambda, y minus y1 upon y2 minus y1 equals to lambda, and z minus z1 upon z2 minus z1 equals to lambda. From here you can see that RHS part is equal, so we can equate the LHS part also. So it will become x minus x1 upon x2 minus x1 equals to y minus y1 upon y2 minus y1 equals to z minus z1 upon z2 minus z1. So this is the required equation of line in Cartesian form, where x1, y1, z1 are the coordinates of one point, and x2, y2, z2 are the coordinates of another point. Let's discuss a question. Suppose the question is, find vector and Cartesian equation of a line that passes through the points 3, minus 2, minus 5 and 3, minus 2, 6. Now what we need to do is, let's talk about P vector. P vector will be a position vector corresponding to the first point, which will be 3i cap minus 2j cap minus 5k cap. And Q vector is the position vector of the second point, which is 3i cap minus 2j cap plus 6k cap. A parallel vector, that is V vector, and it is equals to Q vector minus P vector. So let's simplify it. It will become 3 minus 3i cap plus minus 2 j cap plus 6 plus 5 k cap. After simplification, it will become 11 k cap. So you need to write the vector equation. Vector equation is r vector equals to p vector plus lambda times q vector minus p vector. So it will be r vector equals to p vector, that is 3i cap minus 2j cap minus 5k cap, plus lambda times q minus p vector, which is 11k cap. To write down the Cartesian form, this was the vector form. To write down the Cartesian form, let's write down the points. We had the points like this. So the equation will be x minus x1 upon x2 minus x1 equals to y minus y1 upon y2 minus y1 equals to z minus z1 upon z2 minus z1. After simplification, it will become x minus 3 upon 0 equals to y plus 2 upon 0 equals to z plus 5 upon 11. This is the required Cartesian equation. Thank you.